All right, ladies and gentlemen, another piece of the vectors. It's called the cross product. But before we get to that, let's do a quick review on our three-dimensional vectors. We can do a dot product. A dot product, remember, to determine are these two vectors perpendicular. So let's find out. We're going to take this times this, so we have 3 times 3 plus 2 times 3 plus -1 times 1. Come up with 9 plus 6 minus 1 equals, you got 15. They are not perpendicular. Okay, so we say fine, they're not perpendicular. Well, then what is the angle between them? So we're going to go and do our cosine theta equals, and the same formula as we had before, u dot v over magnitude of u times the magnitude of v. You want to make sure that's a times, not a dot. Okay, just verifying that we got these. Okay, so on top we can say, well, that was 15. On the bottom, I need the magnitude here. So the magnitude of u is going to be the square root of 3 squared plus 2 squared plus 1 squared. So I'm going to see 9, 13, 14. And v, its magnitude, is going to be the square root of 3 squared plus 3 squared plus 1 squared. So I come up with 991, which is 19. So I have 14 times 19, and all that equals cosine theta. Now, we're going to pause, grab the calculator, and see what we come up with. Okay, here we go. We have it plugged into the calculator. Let's go ahead and hit enter, and we come up with about 86.8 degrees. So the angle between the two vectors is about 86.8 degrees. So close to 90, but not quite. All right, so that's two vectors. So in essence, if I have two vectors and they make some sort of an angle, what we want is we want another vector that is perpendicular to both vectors. So that if I have two vectors that make some angle, I have a right angle here, and I would have a right angle here. So it needs to be some sort of vector that's perpendicular to both. That's what the cross product finds. So if I have, again, two vectors that meet at some sort of angle here, I want a third vector that makes a right angle with this one and a right angle the opposite way. There you go. So that's fun and charades with Mr. Moore. To do that, we need to do the cross product. Now the cross product is listed as follows. U cross V. And what we do is we take these vectors, which we could write as 3i plus 2j plus -1, shockingly enough, k, and 3i plus 3j plus 1k. And so we can take those and say, well, wait a minute, that's variables, I, j, k in essence, although they're unit vectors. We can put them into a matrix where all the i's and all the j's and all the k's go together. At this point, the actual cross product is found using minors. Now, minors work as follows. I'm going to have some sort of matrix that goes with I. That matrix happens when I eliminate everything in the row and the column that I is in, leaving 2, -1, 3, 1. Now, I need something for the J grouping. So if I eliminate those components, that leaves me 3, -1, 3, 1. And finally, for K, the same thing happens. I come up with 3, 2, 3, 3K. Now, the only weird thing is, whatever the first matrix is plus, the next matrix is minus, the next matrix is plus. So plus, minus, plus. They alternate. All I have to do now is find the determinant of each of those 2 by 2 matrices. To find that determinant, it's down minus back. So I have 2 minus -3. And I have 3 minus -3. And I have 9 minus 6. Now we have I, we have j, we have k, we have plus, minus, plus. So we come up with 5i. Now this becomes 6, so it's minus 6j plus 3k. Our new vector that is perpendicular to both u and v is going to be 5i minus 6j plus 3k, or 5, negative 6, 3. That's what we're talking about there. That vector should be perpendicular to both. Now, just to verify, what I've done here is I've taken u, and I've taken the new vector we found, and I've done a cross product. That cross product is 0, making it perpendicular to u. I could do the same thing with v, and I would get the same thing, and that would make it perpendicular to v. Even though u and v are not perpendicular to each other, they're perpendicular to this. Next, we're going to talk about area and volume. One other thing we can do with the cross product is in 3 dimensions. If I have 3-dimensional vectors, whatever 3-dimensional quadrilateral is formed by those 2 vectors, I can find the area of that quadrilateral, usually a parallelogram, by taking the magnitude of the cross product. The magnitude of the cross product in this case, 5 squared plus negative 6 squared plus 3 squared. So we come up with 25 plus 36 plus 9. So I come up with 45, 55, 65, 70. Square root of 70 would be the area of that figure. Now, while we're talking area, if we were to have volume, let's take the volume of a figure, solid whose base is, and in this case I can take this and put it back in for the I, j, and the k, and I have 5, negative 6, 3, 3, 2, negative 1, 3, 3, 1, and now I have a full matrix with 3 components, a length, a width, and a height. And so remember, this is perpendicular to the other 2. So to find volume, if I could just get a value for that matrix, well, what is a value for a matrix? That's going to be a determinant. By the way, to find a determinant of a 3 by 3, yes, you could do the 2 rows, but you could also do exactly what we did to find the cross product, and use that to find the value of the matrix. Using the minors, the process we did for cross product, is exactly the alternative method for finding a determinant by hand. Now, we again don't traditionally do this because it becomes much more long and cumbersome. So plus, minus, plus. Find the value of that, you will find the determinant, just as if you were to add the 2 columns on to the end of the matrix as before. Down, 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 back, back, back. Find those 2. So you have method 1, you have method 2, and of course we have the calculator, which is what I'm going to pause and do for you now. Okay, ladies and gentlemen, I have put the matrix into the calculator, so all we have to do is hit second matrix, math, determinant, second matrix, A, and the answer is 70. So the volume would end up being 70. You'll notice, by the way, previously we talked about area between those 2 happened to be the square root of 70. That's just a coincidence. So 70 is the volume of the figure formed by the 3 matrices if you were to put them all together into a 3-dimensional figure. Okay, stay tuned for some homework. All right, ladies and gentlemen, here's your homework. Make sure you write it down, so make a pause. It should follow the previous notes fairly nearly. Thank you much.
Fairly